In this video, we're going to talk about chemistry and how it relates to living things. We're going to look at the three parts that make up an atom. We're going to look at what an isotope is and how that's important and how they're similar and different from each other. We can talk a little bit about what are compounds and how they differ from their elements that make them up. Two main types of chemical bonds. So let's talk about atoms. So atoms are the basic building blocks of matter. Everything, whether it's alive or not, is made up of atoms. And atoms have parts as well. So we call these subatomic particles. And there's three main ones that make up atoms: protons, neutrons, and electrons. So the protons are the positively charged particles found in the nucleus. The electrons are the negatively charged particles in the nucleus, or outside the nucleus, in what we call the energy levels or the electron cloud. And the neutrons are the neutral, or particles that don't have a charge, that are also in the nucleus. So protons and neutrons are in the nucleus. Electrons orbit the nucleus in the energy levels or electron cloud. So like I said, protons positively charged. They have a mass of 1 AMU, atomic mass units, and they're found in the nucleus. Neutrons are neutral particles with the same mass as a proton, and they're also found in the nucleus. Most of the mass of the atom is in the nucleus. Electrons are the negatively charged particles, and they have a mass of 1/1840th that of a proton. So it takes 1,840 electrons to equal the mass of one proton. So we don't really worry about, when we talk about the mass of an atom, the atomic mass, we don't even include the electrons because they're so much smaller than the protons and neutrons in terms of the amount of mass that they have. So elements are pure substances, things that are made up entirely of one kind of atom. All the atoms have the same atomic number, which means they have the same number of protons. The atomic number is the number of protons for that atom. There are some atoms that have the same atomic number. They're the same kind of atom, but they have a different atomic mass because the number of neutrons can vary. So because they have the same number of protons, they're the same kind of atom. But because they have different numbers of neutrons, their mass, which is the protons plus the neutrons, differs. Because they have the same number of protons and as a result in a neutral atom the same number of electrons, they have the same chemical properties because the electrons and the bonding of electrons through sharing or transferring is what determines the properties. So carbon has an atomic number of 6, so it has 6 protons. And all three isotopes, carbon 12, 13, and 14, all have 6 protons because they're all carbon. They all have 6 electrons if it's a neutral atom. If they've gained or lost electrons through bonding, then that differs. But what differs is the number of neutrons. So carbon 12 has an atomic mass of 12. So 6 protons plus 6 neutrons gives us atomic mass of 12. Carbon 13 has 7 neutrons, 6 plus 7, 13. And carbon 14, the radioactive form, has 6 protons and 8 neutrons. So what are radioactive isotopes? These are isotopes that have unstable nuclei. That means that they break down, they give off energy, and they lose protons at a constant rate called their half-life. Because they're losing protons, they actually break down from one kind of atom to a different kind of atom that's stable. Some can be dangerous. Radioactivity can be harmful to living things. Some have scientific and other practical uses. We can use them for things like dating rocks and fossils. Carbon 14 is really good for that. We can use radiation to kill harmful bacteria growing on things. We can use it as a way to follow the pathway of things through a living organism. Or we can use radiation to treat certain forms of cancer. Kills the cancer cells. So most of the time, atoms don't exist by themselves. Instead, they're combining with other atoms. In many cases, they're combining with atoms of different types of elements, and they form a chemical compound, a substance formed by chemical combination of two or more elements in a definite proportion. It's not a mixture of them just kind of randomly mixing, but they combine in very specific ways. And one thing about compounds is the physical and chemical properties of a compound are usually very different from those of the elements from which they're formed. Think about water. Water is a combination of two hydrogens and one oxygen. Well, hydrogen and oxygen by themselves are both gases. They're both fairly reactive. They're both flammable. Combine them together to make water, and you get something that, instead of being a gas at room temperature, is a liquid. So very different properties. So there's two kinds of chemical bonds. There's ionic bonds and covalent bonds. And they differ in how the bond forms. Are the electrons transferred or are they shared? In an ionic bond, one or more electrons are transferred from one atom to another atom. So they form what we call ions, which are charged particles. So in the example here, you have sodium and chlorine. So the most stable arrangement for an atom usually is having a full energy level. And for most atoms, that means having 8 electrons in the outer level. So you can see in the example here, sodium has 1 electron in its outer level. I could try to pick up 7, but that's going to be pretty hard. But getting rid of 1, pretty easy. So it's going to donate that extra electron to chlorine, which has 7 outer shell electrons. And then, now it has 8 when it picks up the extra one from sodium. So now sodium, it's lost an electron. Remember, electrons have a negative charge. So sodium now has a positive charge. It has 1 extra proton compared to the electrons. Chlorine has picked up an extra electron, so it's a negative ion. So we call positive ions cations and negative ions anions. So you can see in the neutral atom of sodium, protons and electrons are equal. Same thing for neutral chlorine. But when sodium loses the electron, now its overall charge becomes positive 1. Chlorine gained an electron, its overall charge becomes negative 1. And the positive and negative charges attract to each other to form that bond. Covalent bonds are formed by sharing pairs of electrons. Again, the goal is to have 8, but instead of the electrons being completely transferred to one another, the shared electrons spend a little bit of time around each atom. So electrons in oxygen, there are 8 total electrons, 2 in the first energy level, 6 in the outer level. So you have 6 outer shell electrons. It needs 2 more. Hydrogen has 1 electron, but it only needs 2 because it's only in that first energy level. So it needs an extra one. So by combining 2 hydrogens, which each have an electron they can share, with the oxygen, we've got a total of 10 electrons here in this outer shells, which allows them to share these electrons. So a molecule is a structure that results when atoms are joined by covalent bonds. So we call this a water molecule, not a water compound, because it's a covalent bond. So there's the shared electrons right there. One other type of force, there are what these other types of forces that interactions between molecules as well. They're not chemical bonds. One example of this are something called van der Waals forces, which are intermolecular forces, forces between molecules, not between atoms. And they're due to slight attractions between oppositely charged regions of nearby molecules. So within a molecule, there are areas that are slightly positive and slightly negative. And so the slightly positive parts of one molecule are attracted to the slightly negative parts of another molecule. An example in biology where these types of forces are important is in the feet and the toes of a gecko, which allows it to climb things. It's got these little tiny, almost hair-like things on their feet, which have these attractions. And even though the individual van der Waals forces are weak, a lot of them together can be fairly strong. It's like taking a bunch of little tiny pieces of thread and twisting them together to make a much stronger piece of rope. And finally, another weak attraction is the hydrogen bond. Hydrogen bonds we're going to talk a lot more about when we talk about properties of water in the next video. There are attractions between a hydrogen atom with a partial positive charge in one molecule and an atom with a partial negative charge in another molecule.